Hi, 7th graders. We're going to talk a little bit about some basics of probability today. So whenever we talk about the word probability, what the definition of probability is, it's the chance or the likelihood of an event happening. And so when we say an event, it could be you flipping heads on a coin. It could be the probability that it's going to snow tomorrow, or that it's going to rain tomorrow. The probability that you roll a 5 on a dice, so it can be a variety of things. And so when we talk about probability, we can express it as a fraction, a decimal, or a percent. So probability is a number between 0 and 1, and again, it can be expressed as a decimal, a fraction, or a percent. Probability also has we can also describe the likelihood of events happening with these words: impossible, unlikely, equally likely, likely, and certain. And they kind of align with the probability numbers. So if there's a 0% chance of something happening, then that would be impossible. If there's a 100% chance of something happening, then that would be certain. If there's a 50%, 0.5, or 1/2 chance of something happening, we can say that's equally likely to happen or not happen. Anything between 0 and 1/2, we can say is unlikely. So just one example of that would be 25%, but the probability could range anywhere from 1% to 49%. And then likely would be anything between 1/2 and 1. And again, it's just using kind of right in the middle there, the 75% as an example. But if there's a 60% chance of something happening, we could say that's likely as well. We also have two types of probability. We have what we call theoretical probability. This is what should happen or what you expect to happen. It's just found by taking the number of favorable outcomes out of the number of possible outcomes. And so favorable outcomes would be the number of outcomes that meet the criteria of the event you're looking for. Number of possible outcomes would be how many possibilities there are for that event. So we'll just do a quick little example here on this spinner. If I said the probability, and so one common way that you'll see questions written is a capital P and then in parentheses the event. So if I wanted to know the probability of spinning green, the theoretical probability, I should say. All right, we're going to look at how many favorable outcomes I have to land on green. So right now there's three chances for me to land on green. And then I'm going to look at the number of possible outcomes. So all of the number of possible outcomes here, I have 8 possible outcomes. There's 8 equal sections on this spinner. So the theoretical probability of me spinning green would be 3/8. Okay. Another way to think of that would be if I were to spin that spinner 8 times, what should happen is I should land on green 3 of those times. Okay. Now, probability, the whole thing about it is it doesn't always work out the way that we would necessarily expect it to. So if I actually spun that spinner 8 times, maybe I would land on green 3 times, but maybe I wouldn't. So then we have experimental probability, which is what actually does happen. And so this is usually, it would be like if you actually performed your experiments and you gathered your data, or it might be your information is given to you in a table or a graph form, and you're using that to come up with the probability. So here, if I wanted the experimental probability of spinning green, I have some results here, okay? And so we're just going to assume that the spinner was spun and somebody recorded their results. So they actually landed on green 8 times. And if we look out of the total number of times, this person spun that spinner 20 times. So 8 out of 20 times they landed on green, which we could simplify to be 2/5. So experimentally, their probability was 2/5. Theoretically, it was 3/8. And if we wanted to think of these as percents, just for a little comparison, so this would be 37.5%. This would be 40%. So what should have happened is we should have landed on green 37.5%. what actually happened is we landed on it 40% of the time. All right, so those are pretty close. Sometimes your experimental might be close to your theoretical. Sometimes it might be really far off. What should happen is the more times you complete an experiment, the closer you should actually end up getting to that theoretical probability. So if we look at a couple of questions, just to kind of solidify those ideas, again, here's experimental probability. So it says use the bar graph to find the experimental probability of the event. We had these numbers 1 through 6 on a spinner, and then these are the actual results. Okay, so it's telling us someone spun the spinner, here are the results. So when we look at this, one thing that we'll want to do is figure out the total of how many times our spinner was actually spun, because so here we spun the number 1 8 times, 6 times for the 2, 9, 11, 9, and 7. And so when I look at this, I see these two add up to 20, and 9 and 7 is going to give me 16, and 8 and 6 is going to give me 14. And so then when I look at the spinner was spun 50 times, okay? And again, I'm getting that information by adding up how many total times I landed on each number. So spinning a number less than 3, experimentally, what actually happened is out of the 50 times, I landed on a number less than 3, so that means 1 or 2, a total of 14 times. And so then I could go ahead and I could simplify my fraction to get 7/25. So this is what actually happened according to this graph. Not spinning a 1. So I spun a 1 8 times, which means out of the 50 times, I did not spin a 1 42 times. And again, we can simplify. We can express probability as a fraction, decimal, or percent. A lot of times the fraction might be the easiest one to come up with. Spinning a 1 or a 3. So now we're going to actually add up our 1 and our 3. So it was 17 out of 50 times. And spinning a 7 was 0 out of 50 times. Or we could just say 0. So that's experimental probability. You're usually given your results in a table or graph form and choosing the numbers based off of the table and the graph. Theoretical probability, again, this is what we would expect to happen. So here it says use the spinner to find the theoretical probability of the event. So when I look at this spinner, I have 6 equally likely outcomes, okay, 6 equal sections here. And so the probability of me spinning red, 2 of those 6 are red, so then that would be 2/6, or I could simplify this to 1/3. Spinning a 1, I only have 1, so that would be 1/6. Spinning an odd number, I'm going to have 3 out of 6. The 1, the 3, and the 5 are my favorable outcomes there, which simplifies to 1/2. Spinning a multiple of 2, that would be 2, 4, or 6. So again, that's going to be 3/6 or 1/2. Spinning a number less than 7 would be a probability of 1, or you could write 100%. And spinning a 9 would be 0. So that's just a little bit about theoretical and experimental probability. The biggest thing to remember about those, theoretical probability is what you would expect to happen. Experimental is what does happen.